I'm going to introduce our next speaker here. So Dr. John Gavloski, he's going to be doing a full rundown on weevils. So Weevils Gone Wild, a review of the newly seen kind of cabbage seedpod weevil here in Manitoba, pea leaf weevil, and alfalfa weevil. So a bit about John. He's an entomologist with Manitoba Agriculture based out of Carman. He conducts all of the monitoring programs for the insects as well as provides information on both beneficials and potential pests. Does numerous presentations across the year. We're really glad to have him here today, and also does the weekly Manitoba crop pest report, which I'm sure many of you are familiar with. He's worked with Manitoba Ag since 1997, and aside from entomology, also enjoys cycling and observing almost any type of wildlife. So let's give him a round of applause and welcome John.
Hey, thank you. Okay, yeah, so as mentioned, what I'll be speaking on is a few different weevils. And before I get to the actual weevil part, though, I'm going to have a little bit of a weevil taxonomy lesson for you. I promise this will be easy and fun. And the reason I think this is necessary is not all weevils are alike. And so at least one of these weevils almost doesn't belong because it doesn't look like the others. So we're going to go over, again, some basic weevil taxonomy, just so people know what weevils look like. And then I'm going to go through the weevils in the order on the screen. We'll do cabbage seedpod and pea leaf weevil first, wrap up with alfalfa weevil. And because the pathologists got to tell us what their favorite pathogens were, not to be outdone, I'm going to tell you what my favorite weevils are, but you're going to have to wait till the end of the presentation. So if I'm somewhat on time, we'll get to that slide, and we'll see some really colorful, neat weevils. These are super cool. Okay, so first of all, a taxonomy lesson for you here. So Weevils 101. First of all, your stereotypical weevil, if we can call it that, the ones you probably learn about in entomology class, we always talk about them having a big snout. The entomology term is rostrum, that's the big snout in front, and clubbed antennae that usually come off of that rostrum. That's your typical weevil definition. The weevil in my photo here is actually an acorn weevil. This is one that has a extremely freaky big rostrum or beak to it. It's a local weevil. You can find them anywhere there's oak trees here. So you can easily see the characteristics in the photos here. Again, the long rostrum, the big antenna. So weevil, and they do tend to have this almost ovalish shape to them, very hard insects. Just as a side note to acorn weevil, not only are they interesting insects, they're also fashionable. The weevil on my shirt here, for those who can see, is an acorn weevil. So there you go. Acorn weevils, freaky, fun, and fashionable. So that's your typical weevil. Now, weevils are also super diverse. This is something I need to stress as well. In fact, they're one of the most numerous groups of anything in the world. So worldwide, there's over 86,000 species. And just to help you put that into perspective, for people who are bird watchers, there's slightly over 10,000 species of birds worldwide. So there's about over 8 times more weevils than there are birds in the world. Just to put it into perspective how diverse weevils are. In Canada, we've got 826 species and 228 species in Manitoba. Majority are not bad. In fact, we've even got good weevils that have been purposely introduced to eat weeds. So they could be good or bad depending on what they're feeding on. Okay, so back to taxonomy here. So within our weevils, our Cuculionidae, we have various subgroupings or subfamilies, just because there's so many of them. So they're broken into these subfamilies. One of those subfamilies is called the minute seed weevils. Now, if you were writing an entomology exam and you didn't study because you were out researching malted beverages the night before, and you want to take a wild guess on what a minute seed weevil might look like, you might think they're small, minute, and they probably feed on seeds. And you'd be right. So, see, I told you, easy and fun. So minute seed weevils, usually fairly tiny weevils that, and the larval stage is usually the one that feeds on the seeds. So they usually lay their eggs into a pot or something and feed inside on the seeds. Now they're a fairly big group as well. There's 36 species in Manitoba, including one that is a weed feeder, but unfortunately we also have the Cabbage Seedpod weevil that belongs to this group. So as the name might imply, Seedpod weevil, they feed on seeds, in this case, seeds of brassicaceous plants, including canola, which is why they are a problem. Now, cabbage seedpod weevil, it's not native to the Canadian prairies or to North America. There's been two separate introductions with this insect. The first introduction happened in Vancouver back in the early 30s. It kind of stayed in BC for a long time until about the mid-90s when it made it east of the Rockies into Alberta and then gradually spread into Saskatchewan and then in 2017 into Manitoba. The second introduction happened in Quebec in 2001. So now there's a population in Ontario and Quebec. That is from a separate introduction than the one that occurred in Western Canada. So as far as their life cycle goes, right now, cabbage seedpod weevils are all in the soil, resting nicely in their overwintering sites. They will start coming out, usually it's mid-spring, I'll say mid-spring, so May into June, you'll start to see them. They really like yellow. I'll get to that in a second. They really, really like yellow, so they're often drawn to anything yellow like canola flowers on the landscape. They lay their eggs right on the pods, which is why they're an issue. The larva gets right inside, feeds right inside the pod, and they will exit the pod. They will actually make a hole in the pod that is easy enough to see. Very visible hole, drop to the ground, and then overwinter as an adult. So here's some cabbage seedpod weevils in the photo. Again, not too big, 3 to 4 millimeters. If you look really hard, you can see the rostrum or the snout on them. But being a smaller insect, often when you do see them, if the snout is curled under, it's not really, really obvious, but if you look hard, you will see that. And just as a heads up too, when you're crop scouting for them, a lot of weevils have this habit of playing dead when they're disturbed. So if you're trying to look at them on a plant, they will drop off really easy. And that's why you have to use a sweep net to sample for them. Just trying to assess them on a plant, they're probably dropping off as you're handling the plant. I mentioned earlier how they really like yellow, and they will often go to the earliest flowering fields. As a result, if you want to do something to lower your risk, don't seed as early as your neighbors. Let them seed first. They will get more seedpod weevils than you will. And there's actually been a good study to back this up. So this was done by Hector Carcamo several years ago in Alberta. And so they planted canola at several different times. They had a late April planting, a early May, and then a later May planting. And you can see the results here. A lot more cabbage seedpod weevils in the earlier seeded canola. The reverse kind of happens for lygus bugs. It's not as dramatic, but you do get more lygus bugs when you seed later. But again, not quite as dramatic, but you get less cabbage seedpod weevils. So you have to decide, okay, well, there's probably other things that are going to factor into seeding dates than that, but if you're trying to base it on insects, what is your biggest threat? And each larva that gets inside the seed will eat anywhere from about 3 to 6 seeds. It's probably, on average, it's probably more like 5 to 6 seeds per larva. You often only get one inside of a pod. There can be exceptions, but often it's just the one. But you are losing 5 or 6 seeds for each weevil in the pods. Now, I mentioned to sample for them, you need to use a sweep net. There's no other way of doing it, really. Just to be walking in the field and trying to look at the plants in front of you. When they're very numerous, you will see some, but what you're seeing is probably just a fraction of what's there. You really get a sense of what's there when you use a sweep net. That's the only way you can do this. So if you're scouting canola or growing canola, get yourself a sweep net. As a tool you really need to sample this insect. And I do encourage people, this is one that we need to start scouting for in Manitoba. And make your decisions based on sweep net sampling. I'm not just on, I'll tank mix something just in case. I'm going to get to that in a minute, why I don't want you doing that. But get a net sample. We have been doing a survey since 2017, actually, in Manitoba, when the first ones arrived, trying to look at the populations of cabbage seedpod weevil. So we've been going out taking our 25 sweep samples and looking at what we find. This table shows you the data, and you can see that from 2017 to 2024, we had relatively low numbers. In fact, the most I ever was able to collect in a 25 sweep sample prior to this year was 6. And just to put that into perspective, the economic threshold is 25 to 40 weevils in 10 sweeps. So in a 25 sweep sample, that would be 63 to 100 weevils. And my highest was 6. So until this year, I was suggesting that, yes, we have cabbage seedpod weevil, but it's at such low levels that it's really not of economic concern. That all changed this year. And you can see what my higher count was here. 226 weevils in 25 sweeps. That was from a field in the central region of Manitoba. So over 2 times the economic threshold, that field got sprayed. So we have now got to the point where we are getting economic populations. So that's something we need to take serious. I'm not aware of a lot of spraying this year. Again, there was that field in the central region. There was some canola and mustard in the southwest that got sprayed. But again, I think for a lot of people, this was a new thing. And people were hearing about it, looking for it. If anyone's aware of any additional spraying, please let me know. I like to track how much control is going on with some of these insects, but I'm not aware of a lot of control. But there was a lot of excitement because it was a new thing that people had to be out looking for this year. And I should mention regarding the mustard, it was brown mustard that they sprayed. Yellow mustard is resistant. Cabbage seedpod weevil does not like yellow mustard. They will not colonize it. They will brown mustard. So if you're growing mustards, grow yellow and you won't have this issue. And so to properly do your sweep net sampling, there's sort of a preferred way, and then there's the shortcut way. I know people are busy, don't always have the time to do 10 sets of sweeps and things that we recommend. And fair enough, you're busy, you've got lots of fields to scout. The ideal sampling plan would be to take 10 samples, pick 5 areas of the field, do maybe an edge and then a more interior sweep. So 10 would be the ideal. Now, if you're really busy and you don't have a lot of time, instead of doing nothing and trying to make a decision based on what the neighbors are doing, take at least 4. Pick 2 parts of the field, do an edge sample, and then go a little ways into the field. There often is an edge effect, and that's why it's good to go into the field and do something further in as well. But do a minimum 4. Anywhere from 4 to 10 is good. Now, if at 4, the threshold, 25 to 40, say you do 4, and you're right around that 25, and you're not quite sure, I would do a few more sweeps and just see what your average turns out to be. But do your sweeping. And again, 25 to 40 weevils in 10 sweeps, that's your threshold. And again, edge effect, sometimes it is a good idea to sample both the edge and the interior. If it's a very heavy edge effect, you may just need to be spraying your field edges. It can happen. As far as products go, you'll notice everything there is broad spectrum. So most of what we have is pyrethroids, and in a couple instances mixed with a diamide, but they're all broad spectrum. And this is an issue because the proper timing for spraying is early flower stage. So you are spraying a flowering crop with a broad spectrum insecticide, which has its risks. And this is something we need to take really serious for anyone growing or scouting canola, because there is a risk to you economically as a canola grower if you spray a flowering canola field. You will get a decent canola yield without any pollinators. You will get a much better yield with the pollinators. There is a pollinator effect in canola. And there's been multiple studies done on this. Probably 10 to 15% is a good guideline, but some studies show even much higher than that, although some of those had really high bee stocking rates. So bottom line, though, you do have this pollinator yield boost. So to try to rationalize that, if I'm going out there spraying sclerotinia anyway, why not just tank mix in a fungicide and be done with it? There is a cost to doing that, an economic cost as well as an environmental cost. So that's why do your scouting, make your decisions based on how many weevils you can find with a sweep net. Doesn't take too much time, but it can help you make a good decision that might save you a lot of money and make a lot of beekeepers happy. One other thing, my last thing I want to mention about cabbage seedpod weevil. Again, they are attracted to the earliest flowering canola in an area. So trap cropping can work. That would mean planting either earlier, some strips around the edge earlier than your interior, or plant a variety around the edge that flowers a bit earlier. What that would do would concentrate the weevils in that edge area, which you could then spray just to eliminate all the weevils in that area. It's been shown to work in research situations. Again, how practical that is, leave it up to crop scouts to determine, but trap cropping, I guess, in theory, does work. Okay, on to weevil number 2. This is the one that doesn't quite belong. This is a group called the broad-nosed weevils. My example here is pea-leaf weevil, but it belongs to a subgroup or subfamily called the broad-nosed weevils. And broad-nosed weevils, again, are what they sound like. They don't have that big snout to them. It almost looks like their snout's been sawed off. So they are a weevil. They're still a true weevil. They just don't have a big long snout to them. And this can be confusing. I did have one or two people send me photos over the summer asking, is this a weevil? They weren't quite sure because they knew this is kind of what pea-leaf weevil should look like, but it doesn't have a snout there. But yeah, there's this group called the broad-nosed weevils. They don't have the big snouts. And they're actually a fairly big group. And this is where I know taxonomy can be frustrating. We give you all these rules, and then we say there's an exception to the rule. And there's, lots of exceptions. This is one of them. And they're actually a fairly big group as well. There's 18 different broadleaf weevils, broad-nosed weevils, in Manitoba. You'll see a few of them in any given alfalfa field. Sweet clover weevil is another one. There's alfalfa curculio. There's a few of them that all have the sawed-off snouts to them. So there's a couple different ways that pea-leaf weevil will injure a plant, and it's really the larval feeding that is of concern to the most part. What you will see, though, in the field is what is evident in the middle slide here. these U-shaped notches at the edges of the seedling leaves. And this is something you'd be easily seeing in late May through June when you've got these tiny little seedling plants. The weevils are coming out. Once you get into the mid-teens, you'll get the adult weevils becoming active, coming out. They're looking, they prefer faba beans and peas. They will make these notches in alfalfa and other legumes, but they don't lay their eggs in those fields. Late in the season, they like to feed on them. Faba beans and peas are what they like to do this to, and then lay their eggs in the field. So you'll see a lot of this notching. Unless it's really extreme and really dry conditions to stress the plant, the adult feeding generally isn't economical. There can be exceptions, but generally it's not. It's the larvae that do the economic damage. What the larvae do is they're strictly underground. You'll never see them unless you start pulling plants up. They're strictly underground. They're feeding on the rhizobium that's living in the nodules of on your pea roots. So rhizobium are what fix your atmospheric nitrogen. So you need rhizobium to have your proper fertility rates. So if you have too many pea leaf weevils eating that rhizobium on you, less nitrogen fixation. That can be a problem. That's why they're such a big problem, is mainly the rhizobium feeding by the larva. I mentioned there can be other host plants, so alfalfa, even soybeans, you'll see them go into and notch the leaves, especially late in the season. But again, late season notching, it's usually not a huge deal. But they're not a pest of those crops. They're not going to be, you won't see the larva feeding on soybean roots or alfalfa roots. That'll be just the peas and the faba beans. Similar journey as cabbage seedpod weevil. They first arrived in in Western Canada, in BC, in the early 30s, early 90s, ended up in Alberta and gradually spread to Saskatchewan. And 2017 was the first year that we found them. 2019 was the first year we found them in Manitoba. So they're a relatively new insect here in Manitoba. We do a survey every year for pea leaf weevil as well. Our survey is a little different though. All we do is go into a field and pick 10 plants at 5 sites, and we count notches on the leaves. Pretty simple survey, and then we compare the results. And this table here shows some of the results from the past year. One of the things that really stands out, and remember, these are seedling plants, generally in the 2 to 6 node stage. And on some of the plants, the ones near Grandview, we had 62 notches on average on a seedling plant. So that's like 10 on every little leaflet. So that's really, really high. Same with the Grass River in the northwest part of the central region. We had some higher counts this year, bottom line. And this series of graphs shows you what's been happening with the population over the past few years. So you can see when they first moved in 2019 they moved in. When in the early 20s, back in 2022, they were starting to get to some more moderate levels. Anything yellow on my map here is kind of a moderate level of population. Green is lighter, and when we get into the oranges, then it's a much heavier density. And again, the graphs kind of speak for themselves. You can see that orange started to creep in to the northwest, kind of got more intense. And then this past year, a lot more orange on the map, and that orange has spread down into the southwest and into the central region quite a bit. So they are on the move. So again, something to be watching for, particularly in the western part of the province, some very heavy populations there. Now regarding management options, you have a couple different options: seed treatments and sprays. I'm going to keep this short. Sprays don't work well at all. Don't expect much from doing a spray. Probably by the time you get your spray on, the eggs have been laid anyway. It's likely revenge spraying. You could do it to try to knock a heavy adult population back, but there's been studies on this, and yeah, the results from foliar sprays aren't good. Seed treatments, under moderate populations, they can help improve yield. Under high populations, less likely. Megan Van Koski's been doing research on this. She's done trials both in Alberta and in Saskatchewan. And yeah, under the more moderate populations, she was able to get a yield improvement from seed treatments. Heavier populations, not so much. So don't expect miracles if you've got a heavy population and you've used one of these seed treatments. You may get some help, but there's no silver bullet right now for pea leaf weevil. So weevil number 3 here. So one last group for you. These are called cocoon weevils, and they do have big snouts. So they're easier to identify as a weevil. My example here is Alfalfa Weevil. This is a cocoon weevil, and you'll see in just a little while why we call them cocoon weevils. Most weevils as a larva are just I'll call it a naked larva in the soil or in a seed or whatever. Cocoon weevils is a bit different. They do make themselves a little cocoon, almost like a diamondback moth-like type cocoon. So their journey is a little different than the other two. Alfalfa weevil was introduced into North America on 3 separate occasions. One of the populations, the earliest introduction, was near Salt Lake City, Utah in 1904. So with the 3 different introductions, the weevils that generated from them are slightly different in the way, some of their biology, their behaviors, so we've given them different strain names. The ones that originated from Utah are called the Western strain, and that's what we have here in Manitoba. Pretty much all the prairies is all Western strain. And again, I'll show you a difference in just a minute here. The 2 other ones, population got introduced in Arizona, 1939. That's called the Egyptian strain, and the 3rd strain, introduced in the east near Maryland, is called the Eastern strain. And there is a little bit of mixing of strains in some parts of North America, but here it is strictly Western strain alfalfa weevil that we have. So a little bit of life cycle here. Adults overwinter, that's the first thing you'll see. To identify them, look for that darker brown stripe that goes down the head and the back. That's the easiest way to identify them from some of the other weevils that you might find in alfalfa. And again, they do have that prominent snout. Now larva, usually what you see in the fact sheets is the nice larger green larva with the white stripe down the back and the black head cap. So that's what they look like when they're fully grown. When they're younger, they're more of a pale yellow color. So when you're doing your scouting in early to mid-June, you might see a lot of the small little yellow ones, but then as they get bigger, you'll start to notice a lot of them are turning this slimy green. They've got the white stripe down the back, black head. That's alfalfa weevil larva. If you're seeing some that have a brown head capsule, that's probably not alfalfa weevil. There's other weevils in alfalfa, but I'm not going to get into that because at some point, Sonia's going to hold up that 5-minute warning card on me. So the reason that they call them cocoon weevils for the family, this is what the cocoons look like. Again, it's somewhat diamondback moth-like. What they've done is produce this kind of silken cocoon case, but they usually embed a lot of leaf fragments and things within it. So it's a really interesting looking case. Now this is where some of our strains differ. Our Western strain, you will find these cocoons usually on the ground, on the soil surface amongst the leaf litter, where in the Eastern and Egyptian strains, the cocoons are usually attached right to the alfalfa plants. So again, one of the differences between the strains. Another difference I'll just throw out there, I'm not going to get into it, but there's a type of bacteria called Wolbachia that actually provides some benefits to certain insects. Western strain has them, the other strains don't. So again, the strains do differ somewhat. What alfalfa weevil likes to do, it likes to feed on the higher leaves on the plant. So They're usually up on those upper leaves. They will feed on, they have a type of feeding we call it skeletonizing. They like the nice, soft, juicy tissue of the leaves, and they'll eat that, but they will often leave the veining. So you get this network of veins left over where all the green soft tissue has been eaten out. We call it skeletonizing. A lot of insects do that. That's the way alfalfa weevil larvae feed. So you have the skeletonizing effect on the plants. And this past year, we did have several areas of the province where we had high levels. Some of the people who were growing the crop for hay, they were cutting the crop early as their plan of attack to manage it, which can work. I'll get to that in a second. Other people were using insecticides, so there was a combination. The tricky part, if you're an alfalfa seed grower, you can't cut your crop early, and you then have to resort to using foliar sprays, and that is not so easy. I'm going to get to our sprays in just a little bit, but they don't always work that well, and your options are few. So yeah, I'll talk about that in just a second here. As far as thresholds go, so here's a threshold for alfalfa seed. 20 to 30 third or fourth instar larvae per 90-degree sweep. I don't have a lot of confidence in this. I've tried to track the source of this threshold, and it leads me back to a study that was done, I believe it was in California. It was basically an insecticide trial, and they tried to develop an economic threshold from it, but there isn't really good data to support the threshold that they came up with. So it's really weak data. And I've been pushing for years that we need to have a better threshold for alfalfa weevil in seed alfalfa. There is a group at the University of Alberta who is starting to look at this, so we hope to be able to have something better for you down the road. This seems to me way too high, but I mean, it's what we got right now. The other way you can do it is 35 to 50% foliage tips showing damage, which until we refine things might be your better option. Because again, I think the other one's way too high. For hay crops, it's a bit easier. You can do weevil counts and figure out how many you have per plant. And if you have, if your alfalfa is basically less than 30 centimeters, 1 larva per stem would be a good threshold. If your alfalfa is a bit taller, say it's between 30 and 40 centimeters, 2 larvae per stem is a good threshold. But once you get to 3 larvae per stem or above, you probably have an economic population. So those are good guidelines for thresholds. If you do end up not spraying, or even if you do spray, keep an eye on that regrowth. Again, the sprays don't always work tremendously well. And nowadays, the alfalfa, the regrowth happens so quickly that often you don't have a chance for the larva to die before the regrowth comes up. An easy way to scout for them is to take a bucket with you, take some pruning shears, clip the plants, shake the plant over the bucket. Do that for a series of about 10 stems, do that in several parts of the field, and figure out your average. We call it the shake bucket technique. It's pretty straightforward, simple, and easy, is what it sounds like. Yeah, so that's the easiest way for a hayfield to do an assessment. You can do sweeps, but there's been good data showing that sweep net sampling is not as accurate as the shake bucket technique. So that's why people like using the sweep net. It's easy, but the shake bucket technique has been around a long time, tried and tested, and it works. So use that one. I mentioned about cutting and how that can be effective. The way that works is you cut the field. You may have noticed that the larvae, this is something characteristic of weevil larvae, they really don't have functional legs. So if you cut their host crop, they can't just crawl across the road to a neighboring field or crop. They're stuck there. And if the crop is drying down, they're going to desiccate or starve to death, and you've got nothing but dead weevils. That works. It can be a cheap and effective way of managing alfalfa weevil. So you do have that as an option in your hay crops. You don't have that option with your seed crops. Now, our insecticides. And I've put a notes column in my table here. So these are all the insecticides registered for alfalfa weevil. It's not a long list. You've got a few different groups in here, but you'll notice that some of them, your Coragen and the generic versions, suppression only. Coragen is a really, really good product on Lepidoptera and grasshoppers. For the beetles, it works well on some, but some of the beetles, it's basically suppression. And unfortunately, alfalfa weevil is one of those. You will get some kill, but again, don't expect to see nothing. It doesn't work the same way it does on your caterpillars and grasshoppers. Legon, Saigon, that's your dimethoate, same thing. Pretty nasty product, systemic, but it doesn't do full control. It's suppression only for the alfalfa weevil. And there's 3 of the products here, 3 of the lines on my table that are for seed production only. So if you're a hay grower, you've got your chlorantraniliprole, your Coragen, suppression only, dimethoate, suppression only, or malathion. Doesn't say suppression only on the label, but I think the suppression as well, and it's hard to get. So for hay growers, it's tricky making that decision. If you do have to spray, what am I going to use? So, yeah. The other thing I should mention is there has been resistance to alfalfa weevil that has started to show up in Alberta. Boyd Morey is doing some research on this, and in the Alberta populations, he can find truly resistant weevils to pyrethroids in Alberta. I was helping Boyd out this year by doing some tests in Manitoba. Boyd was sending me vials treated with daltemethrine, and the Manitoba Forage Seed Association, they had some of their people out doing a lot of collecting. They were bringing us the weevils, and we were putting them in our test tubes. Luckily, things were dying for me. So I've got no evidence based on this year's results that we have any resistance in Manitoba, but we will be continuing that research. We just did a few fields this year. We'll be hopefully expanding that research just to see if by chance we have any resistance in Manitoba. And I should mention that a huge driver for alfalfa weevil cycles is parasitoids. And one in particular, the one on your left, Bathyplectes cuculianus. It's, there's no easy name for it, sorry about that, but it is our most effective parasitoid for alfalfa weevil. It probably is a big determinant in what drives their cycle. It will parasitize the larva. And another one, Oomysis, is helpful. David Osterman did some collecting a few years back, and we were putting them in little trays and rearing parasitoids out of them. And the Bathyplectes at times was hitting 30% range or higher. So they can be quite abundant at times. Oomysis wasn't quite as prevalent, but they're there as well. So with this complex of parasitoids, that can help drive the cycles. And that's again why we like to emphasize spray when you need to, use the thresholds, don't spray needlessly, because you do have all these good guys that normally will help keep that cycle quite regulated for you. So just spray when you need to help these guys do their job. I actually have time. I didn't think I would be able to get to this slide, but I am going to be able to cover my favorite weevils. So this is a group called Eupholace. And Eupholace, they're super colorful. They're quite diverse. There's about 60 to 70 species of Eupholace worldwide. These ones here come from that Papua New Guinea area. They're in my collection at home. I have but believe it or not, I have a weevil collection. I've got, let me see, a few different Eupholace in there. And so these come from my home collection. The green one's really funky and cool, as is the other one on your left. The other one that I will give a runner-up nod to is the giraffe weevil, which I also have in my collection. It's from Madagascar, and they've got really, really long necks. like giraffe-like, and they fight with each other. And so weevils can be super cool. These are some of my favorite ones. And so just to close, we've learned that weevils are super diverse. So lots of different weevils. So get to know the groups. They can be good or bad. You do have weevils that are beneficial, some that feed on weeds and weed seeds, a lot that are kind of more neutral. And then you do have your bad weevils. You've got some that feed in the ground, like the pea leaf weevil on nodules. You've got some that feed up on the plant, like alfalfa weevil, and then you got some that feed right in the pods, right on the seeds, like cabbage seedpod weevil. So, and there are no ugly weevils, so I'll end with that. I've got nothing else to say. So, no, there aren't. I think we have time for a question or two. This is remarkable.
While we're waiting for the runner, what's the actual yield loss from pea leaf weevils when we see economic threshold reached?
Oh, so okay, so there are economic thresholds for pea leaf weevil. However, this is a big however, it's almost meaningless because the economic threshold is for spraying for the adults and the chemicals don't work too well. So we do have thresholds established, but again, we don't have anything to help you make decisions on how to manage the larvae, which are the damaging stage. So they do exist, but we don't really push them or promote them because, yeah, the spraying for the adults just doesn't work well.
Why did the population of cabbage seed pod exploded in 2025?
Why did it explode? I wish I knew. We speculate on this one. I don't have any good data on baseline parasitoid levels, and I don't think it would be being a break from the parasitoids. It's probably very much weather-related, weather-driven. But the magnitude of the explosion really took us by storm. We discussed this. We had our Western Forum on Pest Management just over a month ago, and entomologists sitting around trying to discuss this topic. Nobody really knows why it exploded to that magnitude. And it was even more in Saskatchewan than we received here. There was a lot of spraying in Saskatchewan. So yeah, short answer is we don't know. I'd be guessing if I told you something else.
Hi, yeah. So just thinking, you mentioned that the chemical sprays weren't terribly effective on the alfalfa weevil. Are there certain best management practices that the farmer can do early in the season or in the fall to break up the life cycles that are non-chemical related? For example, burning or some kind of tillage?
Yeah, that's a super question. And people have researched burning. It doesn't work terribly well because a lot of the weevils will actually move out of the field. They're looking for sheltered areas, kind of flea beetle-like, where they overwinter. So burning, there's been multiple studies on that. It works for some insects, but not alfalfa weevil. Things like alfalfa plant bug that lay their eggs into the stems, it works better on. But yeah, there's not a lot you can do as far as cultural controls. Unfortunately. The early cutting certainly can be helpful, but as far as field prep, tillage versus non-tillage or burning, there's no silver bullet that way.
Okay, well, let's thank John. Thank you so much.
Thank you.
John.
You're welcome.
And little known fact, John is also known as Commissioner John in our office because he also runs our office hockey pool. So you can ask him about that too.